This is the course of data mining, and I think I have some mistakes. First of all, I would like to say sorry. 죄송합니다. Because there are two slides that are missing in the PowerPoint that I shared to you. So please allow me to repeat a little bit about this section. So when you learn about the data discretization methods, you learn that there are 5 methods. First is the binning, and then histogram analysis and clustering analysis, decision tree analysis, and then the chi-square analysis. And I would like to explain that this binning is a simple discretization. Okay. So when you go to orange, you will see the equal width and equal frequency. And I would like to explain this concept to you. So equal width, or we call it distance. Okay. We want to divide the range into n intervals of equal size, or we call it this is uniform grid. And if a and b are the lowest and the highest value, okay, so this is a is the lowest, b is the highest of the attribute, then the width of the interval, width, okay, or we call it the distance, will be w. W equals to b minus a divided by n. Okay. So b minus a divided by n. Okay. The most straightforward, but outliers may dominate the presentation. Okay, because we just want to make the width, okay, w, based on the n is the n intervals, and so there might be some outliers. Okay. Skew data is not handled well for this equal width. The other approach, we call it equal depth or equal frequency. So we want to divide the range into n intervals. It's containing approximately same number of sample. So the idea is you want to get the same frequency. It is good data scaling, but managing categorical attributes can be tricky. So let's see the example. So with the binning methods, we can do the data smoothing. For example, this is a data for price, and we are sorting the data. Let's say the data is in dollars. So we have 4, 8, 9, 15, 21, 21, 24, 25, 26, 28, 29, and 34. So in order to partition the data with equal frequency or equidepth, and let's say we have 3 pins, then the pin number 1, it is 4, 8, 9, 15, yeah, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 data. Then the first pin will be 4 data, the second pin will be another 4 data, and the third pin will be the last 4 data. Then this pin will be 4, 8, 9, 15. The second pin, pin number 2, will be 21, 21, 24, 25, and the third pin will be 26, 28, 29, and 34. So using this kind of pin, we can do the data smoothing. Data smoothing means we want to compact the variance. So the variance of the data should be reduced. So the smoothing can have several methods. For example, we want to smooth the data by means. So you can see the means from this 4 plus 8 plus 9 plus 15. So the mean is 9. Then every data can be changed into 9. Second one, we have this data, and if we calculate the mean, it is 23. So we can change to the 23. For the bin number 3, yeah, this is the data, and we can just smooth the data by bin means. What about the bin boundaries? We can smooth the data between boundaries by looking at the nearest boundaries. For example, I have the boundaries of this bin is 4 and 15. So I need to know for every data, and the minimum and the maximum will be the same. However, we can smooth the data in between 4 and 15. So for the data 8, 8 will be 4 because 8 is closer to 4 compared to 15. Okay. In order to go to 4, there is 4 intervals. In order to go to 15, there is a 7 interval. Then we just put the boundaries 4 because 4 is the smaller in distance compared to 15. What about 9? 9 is also the same. It has a distance 5 to 4, but it has a distance 6 to 15. So the boundaries become 4. The bin number 2 is also the same. We have 21 and 25, which is the minimum and the maximum. For the 21, because it is the same, and for 24, because it is closer to 25, then we change to 25. What about the 26, 28, 29, and 34? Yeah, we have this number. The 26, 28, 29, it is closer to 26, so the boundaries will be 26, and the upper boundary is 34. What about the equiwidth? The equiwidth, it means I want to find the width by finding the maximum, which is 34, okay, and the minimum, which is 4. And let's say I want to split, or I want to divide the data into 3 intervals. So I have 3 buckets, or I have 3 bins. 34 minus 4, it is 30 divided by 3, then it is 10. It means the interval or the width is 10. So I can have the width 4 until 13, 14 until 23, 24 until 34. Okay. So because 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the width is 10. Okay, we call this is the width is 10. Every number in between 4 until 13, it will be in the bin number 1. So for 8, 9, it will be in the bin number 1. For any number between 14 and 23, it will be in the bin number 2. So 15, 21, it will be in bin number 2. And the number between 24 and 34, it will be in the bin number 3. So you can see the distribution of this bin is different with the distribution of this one. This equal frequency is different with the equal width. Okay. So this is what I want to explain to you before, but I missed the PowerPoint. I'm not sure why I delete this content in my PowerPoint, but yeah, you can look at the PDF file that contains of this approach. So That's why I explain this one. What is the difference between binning and clustering? So you can look more details later when we learn about clustering. But for the binning, yeah, it is more simple, or this is just using a very naive way compared to the clustering, which is based on the algorithm. Okay, I will stop the video now. Thank you very much for listening and have a good day.